All right, let's look at the first homework question. Let's go to 120. And by subject. And let's start with 6.2. Well, 6.1, I've got quite a few. Let me get rid of these. There's 6.1. Delete. All right, 6.1, 25.8. 6.1, 25.8. Oh, this is the life insurance policy. 6.1, 25.8. And you got a life insurance policy, and it looks like from the insurance company's view, you got to form a table. And with that, let's see. It don't matter really how you do it. Dead, alive. And you can do it that way, or you can do P and then P of X. You can do it that way and put dead or alive. Either way you do it. I'm going to do it this way since the probability distribution is P and P of X, or X, sorry. P of X. We'll do it that way. All right, so what is the probability of being dead? Well, it's going to be the complement of that, because that's the probability of being live. So 0.999544. So 0.00046. Somebody check that for me and make sure I got the right complement. Subtract that from 1. And if you're dead, the insurance company is going to lose money. And if you're alive, they're going to gain that payment of, what's the payment? $310. And if you die, that's going to be $299,690. And the mean is equal to the, what do they call this thing? The expected value. And that says that in the book also. We didn't cover this one. I don't know if we covered it or not. I think we did. But if we didn't, the mean is always the expected value. If expected value is positive, then that means you got a profit. If the expected value is negative, that means you got a loss. So to find the mean, you take X times P of X and add it to X times P of X. So these two multiplied together plus these two multiplied together. And we will do that on the calculator. So negative 2, let me get out of this. Second quit, clear. So negative 299,690 times 0.000456 equals plus parentheses 310 times 0.999544. And that gives us 173 bucks. Positive, so that means a profit. So positive 173.2. So therefore, the insurance company is making a profit. So 173.20. Okay, 173.20, that's the answer. And it's making a profit. So it's going to be make a profit, make a profit. And it should be for 1 year. Unless they count that as a profit each month. It could be either one. I'm going to go for the year. 173.20. Because it is a yearly payment. If it was a monthly payment, then it would be for 1 month. Okay. That's that question, 6.217/8. 6.217/8. 6.217/8. Oh, this is simple. And this is NPX. So since it's precise, it's NPX. So since it's an equal sign, x is equal to 9. Since x is equal to 9, you got to use binomial PDF for precise. Equals means precise. So that's going to be binomial PDF. N is 10.8 is P, and 9 is X. So take your handy dandy calculator and second vars, binomial, PDF for precise, and that's going to be 10.8 and 9. And your probability is 0.27. I would write it in 4 digits because you got to get used to doing that. 0.2684. And that is your answer. .2684. Next question. Uh, 6.219. 19/9. 6.219/9. Same thing. Since it has x is equal, you're going to use binomial PDF. So that's going to be same thing, binomial PDF and 60.99 and 58. Sorry. So second, enter, and we're going to do 60. .99. We'll have to put an insert in. And 58. And enter. 0.0988. So you got a 10% chance of hitting 58. 0.0988. Y'all it's awful quiet. I hope y'all don't have any questions. I take quiet as you understand. All right, 6.235/14. 6.225/14. Need a little help. All right. According to the flight stats, American Airlines from Dallas to Washington are on a time 80%. So P is equal to 80%. P is equal to 0.8. Suppose 17 flights. That would be N is equal to 17. And the number of on-time flights is recorded. Explain why this is a binomial experiment. Well, you've got a fixed number of flights. It's either going to be on time or what? Not on time. So you got a binomial. So it's got all that stuff. Determine the value of N and P. We already did that. Find and interpret exactly. What does exactly mean? It means equal to. So C is going to be N, or X is equal to 11. Fewer than 11. So D is going to be X is less than 11. At least. E is going to be X is less than or equal to 11. And F is going to be 9, 10, let's see, between 9 and 11. So the probability of 10. And there is your answers. Now go ahead and punch those in. This one is equal. This one is equal, so you'll use PDF for precise. This one is cumulative, so you're going to use CDF for cumulative. And this one is cumulative also, because of the inequality. All right, so go ahead and do those. So second bars, binomial PDF, and we got 17 flights, a 0.8 probability. What is the probability of 11 being late or on time? Whatever it's asking. 0.0680. 0.0680. Let's go ahead, and since we're doing PDF, let's go ahead and do 10. Second enter, and I'm going to change that to 10. 0.0267. Okay, now we're going to go to second bars. and going to CDF for cumulative. And the same thing, 17.8. And X value for this one would be 10, because you can't include 11. It doesn't have an equal sign here, so that would be 10. And that is 0.0377. Now for this one, less than or equal to 11, we're going to do up to 11, because 11, you can actually include 11. So that's going to be second enter, and change that to 11.1057. There's your answers. I think I may have E wrong. Didn't E say at least or at most? At least. That means the lowest number. I thought I had that one wrong. Okay, let me turn that around. At least means the lowest number is 11. So that means 11, 12, 13, 14, up to 17. So that means all of these. So I need to take off, I need to subtract this from 1, because this is up to 10. D is up to 10. From 0 to 10. So if I subtract this one, 0.0377 from 1, that will give me at least. At least means that the lowest number is 11. So that means I need to turn this around. X is greater than or equal to 11. At least. Okay, so 1 minus, so what is that? 0.9623. Somebody help me out. 0.9623 is equal to that. So between 11 and 17 flights, 96% are going to be on time. And I'm just going to take this green right here, and that 0377 represents 0 through 10. So if I want to find 11 through 17, I just subtract that from 1, use the complement. So let's see what we got. 0.0377. Oh, wait a minute. Fewer than 11 flights. Oh, we got that one. Okay. Fewer than 11 flights. And that's just 4 flights. You multiply that and you just move the decimal. Okay, 9623, we got that. And 1031. Okay, I don't understand why I got that one wrong. Between 9 and 11 flights. They're not including 9 and 11. That means 10, right? The probability that between 9 and 11. What's between 9 and 11? 10, right? They're not including 9 and 11. Make sure I type that in right. So second vars binomial PDF point or 17.8 and that'd be 10 between 9 and 11. 0.0267. I think they're including 9 and 11, but they're not supposed to because it says between 9 and 11. I agree with my 0.20267, but evidently they are including 9 and 11, but you would have to add all three of them up. So I'm going to see if that's what they're doing. I don't agree with it. 0.0267, that's for 10. 9 is going to be second, enter, 09, enter. That's 0.0084. And then 11, second, enter, change that to 11. 0.0680. 0.0680. That's not going to equal what they've got. I don't know what they're doing. So I'm going to add those up. 0.0084, 0.0084 plus 0.0267 plus 0.0680. 0.1031. That's not right. I mean, that's what they got, but if I ask you to tell me what is between $9 and $10, somebody tell me what's between $9 and $10, or $9 and $11. What's between $9 and $11?
$10.
10.
Well, why didn't you tell me 9 and 11? It does not include 9 and 11. I don't agree with that. I don't agree with that at all. But that's what they did. They included 9 and 11. I don't agree with that. Right here. This is what they did. I'm going to circle it in pink because I don't agree with it. This is the correct answer. That's 10. 10 is between 9 and 11. Now, what they should have said, what is the results of, or what is the probability that 9 to 11 flights are on time, or something to that effect? Not between 9 and 11, because between 9 and 11 is 10. I don't agree with that question. Now, the rest of them are okay. F is, they shouldn't use between. If they're going to include 9 and 11, they should say 9 to 11 flights. Okay. I didn't read it. There's the word right there. I didn't read it. I didn't read this sentence right here. I just stopped right there. That's what guys do. We don't read. There it is right there, inclusive. Highlight that word. That means include 9 and 11. If I'd have read the whole question, I would have picked up on that, but I didn't. I'm sorry, my male genes. I can't help that. We don't read directions very well. All right, next question. This is 7.2, 11/5. 7.2, 11/5. And let's see what it says. So far, except for that last question. Okay, this one is, I don't like the way this question is written because it's just all over the place. It's just 3 questions, but the way they word it, it's all over the place. A, what is the probability of being left of -1, and right of +1? B, what is the probability of being to the left of -1.32, left of -1.32, and right of +2.32? And then the third one, I thought there's only 2. I guess there's only 2. I thought there was 3. Okay. So we got to get our handy dandy curve out. It may be 4 or 5 of y'all printed out. And this is going to be 0, 1, 2, 3, -1, -2, -3. And they want to know, get my handy dandy ruler out. Let me get my highlighter. Let's go with blue. And -1 is right here. And +1 is right there. What can you tell me about these two? What can you tell me about these two? I'm looking for a mathematical word. What are they to each other?
Equal.
I'm sorry, what?
Equal.
Equal, yes. I'm looking for an S word. What's the S word I'm thinking about?
Symmetrical.
Symmetrical, good. Write that down. Let's write that down in red. Because if it is symmetrical, you don't have to do as much work. Why?
Priority 1 message coming in on secured channel.
If they're symmetrical, you just have to multiply by what? 2, because they're symmetrical. So find the area over here or over here and then multiply it by 2. So we read from left to right, don't we? So that's -infinity, and that's +infinity. We can't type in -infinity. So -9999 and +9999. Now, if you want to do both of them together, you can, but that's just a waste of time. Empirical rule says 1 minus 68 because these two are not used. So 1 minus 68% is equal to point what? 32? So by the empirical rule, we estimate the answer is going to be around 0.32. So let's go ahead and add this one up. So we're going to go to normal CDF, second vars, normal CDF, negative 99999. And we're going to add the negative 1. Paste and enter. And that's 0.15. Let me get my blue marker here. 0.1587. And I'm going to multiply that by 2. 0.3173. So the calculator has given us 0.3173, and that is our answer. Okay, so let's do the next one. Get my handy dandy picture. I wonder if those people that didn't copy these, I wonder if you've gotten tired of drawing the picture yet. You get tired of drawing it after about the 5th or 6th time. So this one says, let's go with our pink again, or I'm in blue. Negative 1.32. 0, negative 1, negative 2, negative 3, 1.3, so 1, 2, 3. So there's 1.32. And 2.123, 2.32, that's a third, and that's a third. So negative infinity, negative 9999, negative 1.32, positive infinity, 9999, and this is 2.32. So we cannot multiply these by 2 because they're not symmetrical. So these are not symmetrical. So you're going to have to add them if they ask for the total. These are not symmetrical. Therefore, add up instead of multiply by 2 if they ask for the total. So the empirical rule says, let's see, this is 2/3 of 13.5. So let's say 14, or yeah, 14. 14 divided by 3 is 4.7, maybe 4.5. We'll just say 4.5. So that'll be 4.5 and 4.5. We'll say that's 9. And that's 2.35. And that's 0.15. So 2.5 plus 9 is 11.5. So by the empirical rule on this side, I get 0.1150. And on this side, gracious, we don't even have, let's see, this is a third of 2. Gosh. Let's see, 3 will go into 23, 7.7. So that'd be 1.4. And then here is 1.5. So we'll just say 1.5. So 1.5 is 0.150 and add that to, so 0.1350. By the empirical rule, I get 0.1350, I think. No, 0.1300. So let's see what we get. So calculator, second bars, normal CDF, negative 9999 to negative 1.32. Empirical rule says 0.1150, 0.0934. So the calculator says 0.0934. And the other side, and I'll just save that, stow, alpha, got an L in here somewhere for left, clear, second, bars, normal CDF, 2.32 to 9999. We got an empirical rule 0.0150. Ooh, close on that one. The calculator says 0.0102. So I'm going to add that to alpha left. And the total is 0.1036. Calculator equals 0.1036. And you may say, well, Hubert, you were way off with the empirical rule. The closer you get to the tails, the more off you're going to be. The closer you get to the tails, because it's just so small. And there is the example. So the empirical rule, I got 13, and it came out to be almost, well, 10. So that's your answer, 0.1036. 0.1036. That should be this one right here. 0.1036. And they asked for the pictures. Well, we done drew the pictures. So hopefully y'all have copied these off, because I'm going to tell you something. 7.1 and 7.2, it's awful to have to draw all those pictures. And if you don't draw them, you might make a mistake, guys. Because the guys are the ones that won't draw them. Next, 7.2, 13/5. 7.2, 13/5. I'm just going to write it on the thing. 7.2, 13/5. The z-score at which the area under the standard normal curve to the left is 0.57. So we need 0.57. Area to the left is equal to 0.5700. So we got to draw it. This is negative infinity. We read from left to right. So 0.57, there's 50 right here, 0.500 right there. So let's see, 34 divided by 4 is 8. So 58 would be right about here. So I'm going to guesstimate by the empirical rule that 58 or 0.5700 is going to fall around, let's see, that's a quarter, 1.25 or 1.2. I'm going to say by the empirical rule, 1.20. Okay, so we don't know, so we got to calculate it. So we're going to use, since we're given an area, and we got to find a z-score, we need inverse norm. So second bars, inverse norm, and 0.5700. And it is left because they said to the left. If it said to the right, you would do right. Paste. And I think it's going to be around 1.2. Ooh, I'm sorry, 0.2, not 1.2. 0.2. I'm sorry. All right, that'd be 0.17, So by the calculator, we got 0.18. That's your answer, 0.18. Z-scores are 2 decimal points. Area is 4 decimal points. I don't know why this is the only book I've ever seen that doesn't do 4 decimal points for area. 0.18. Next. Next one is 7. That's the same one. 7.219/12. 7.219/12. 7.219/12. I do not agree with the way this one is written. This is the complement of 0.1100. I'm going to write it, but I'm going to disagree with the way it's written. So z sub 0.1100. Basically, they're wanting the area of 0.8900. That's what they're wanting. So when they write it like this, that means they want the complement area. Complement area. So the complement area of 0.1100 is 0.8900. So inverse norm, excuse me, second bars, inverse norm, 0.8900. Excuse me, I always yawn on Tuesday and Thursday, and I don't know why. 1.23. So technically, 1.23 is right about here. This right here is what they call Z of 0.1100. I disagree with it. I don't know why my Why is my... Oh, that's the word processor. Sorry. When you see this, when you see Z.1100, that's not what they want. So let's highlight that. I've never seen it like that in all my years of teaching. They usually put a area or a P, and they put a hat or a mark over it. I've never seen that before. So it must be some of that new Tide Pod stuff. Okay, this is what they're really wanting. They're wanting the complement of 1100 or 0.1100. So you can mark through this and put 0.8900. That's what all this is. Not a fan of this one, so I probably would not, unless the computer generates it, I would not pick this one for a test question because I'm not used to seeing that. I'm used to seeing this. That means the probability, I want the complementative probability of 0.1100. Or you might see something like this. This is what I'm used to seeing. Because when you see that Z, you think that's a Z-score. Okay. Y'all still very quiet. Y'all feeling good or y'all just not communicating? Thank you. Appreciate it. (7.2), we just did 19. 7.2, 23/14.
You got a work email.
I love it when people think they're the only people that have questions. That's not true. Usually, if you have a question, that means everybody else has a question. All right. P is, what is the probability of X being greater than 39 with a mean of 50 and a standard deviation of 7? (50, 57, 64, 71, 43. Y'all got to help me out here. 36 and 29. Please check me out and give me a thumbs up on those numbers, please. Thank you. So where's 39? 39 to be right in here. And they want the numbers, this is to the right. Numbers greater than 39. They want this side. Well, by the empirical rule, because this is 39 right here pretty much. By the empirical rule, half of 13 is 7. This is 9. I'm going to say 0.09. Let's see, that's 91. I'm going to say, by the empirical rule, 0.9100. So let's see what it is going from, and we got an old calculator. If you got a new calculator, you know how to type it in. But if you got an old calculator, it's going to be 39 minus 50 divided by 7, which is 11 divided by 7. And what is 11 divided by 7? Somebody give me that number, please. 2 decimal places. 1 point what? 47. What?
57.
So if you got an old calculator, you're going to go from 1.57 negative to 9999. If you got a newer calculator, you can type in the mean and the standard deviation, and it will tell you the answer. So let's go to normal CDF, second bars, normal CDF, negative 1.57. If you have a newer calculator, you could just type in 39 and then fill in the mean of 50 and a standard deviation of 7, and it would give you the same answer. Upper is 9999 and paste. Okay, they got 0.9418, and it is more accurate. So the calculator gives us 0.9418, and that is your answer. So we're a little bit off, but the empirical rule is for estimation anyway. It's not for detailed. 0.9418. So it's this one right here, 0.94. Okay, they said, okay, round to the 4th decimal place. Okay, 9418, that'd be close enough. Or 9418 does not, that rounds to the 3rd. So, but there it is, 0.9418. That's the type test question you're going to see on the test. Not too long, kind of short and sweet. Next, 7.225, 7.22515. 7.2, hold on, let me get my drawing. God, we done went through 10 drawings. Because I printed out 10 right before class. 7.225/15. Just curious, somebody give me a hand if you printed out these curves. Saves you a lot, doesn't it? Again, there's only two or three. I knew it was going to be only 2 or 3. What I want to know is those people that didn't draw them out, do y'all like drawing these things every single time? And they're not going to say anything. 49. Oh, God, I hate when they do this. That'll be 56. Oh, gosh, what's next? 65. No. Shoot. 63. 70. Y'all check me, please. 49 minus 7 is 42. 42 minus 7 is 37. I don't know. 35. 35 minus 7 is 28. Somebody check my math. I suck at subtraction. Somebody give me a thumbs up after you check them. Okay, thank you. And they say they want to know less than equal to 40. Well, this is 3 right here, so this is 38. So 40 would be right in here. And they want less than 40. So by the empirical rule, I don't know, that's probably a third maybe. So that would be 13 divided by 3 be 4. So 4 and point, so 2.065, 0.0650 by the empirical rule. That's what I get. Negative infinity. And this is going to be, what did it say? 39, hold on. 40. So 40 minus 49 divided by 7 is negative 9 over 7. Somebody give me that decimal, please. Negative 1.9, or what is it? 1 point what? Not 1.9.
Got negative 1.285.
2 what?
285.
So 1.29. So take your handy dandy calculator and do second vars normal CDF negative 9999 to negative 1.29. And if you got a newer calculator, you would type in negative 9999 to 39 or 40, and then 49 for the mean and 7 for the standard deviation. 0.0985. So the calculator says 0.0985, and that is what we're going to go with. 0.0985. So there's your answer. 0.0985. And the last question that was sent to me, 7.27/3. This is the last curve that I have. 7.27/3. I don't know why I didn't put it in order. And enter. Okay, I'm going to write these in different colors. Okay, it says to the right of z equals to 0.73. Z is equal to 0.06. Z is equal to negative 1.11. And Z is equal to negative or 1.32. Okay, so there's our, and they want to know to the right. So the first one is blue, 0.73. So we got a mean of 0 and a standard deviation of 1. And 0.73, well, 0.75, 1, 2, 3. 0.75 would be right here. 0.73. And they want to know to the right. By the empirical rule, 34 divided by 4 is 8. So that's going to be 8 and 13.5 and 2.5. So by the empirical rule, we say 8, let's see, 8 and 16 is 24. So we're going to say 0.2400 for the empirical rule. And we're going to go normal CDF. From 0.78 to 9999. And the actual calculated answer is 0.2177. So that's the blue answer. 0.06 in green. 0.06. Well, 0.06, that's 0.25. 0.06 is going to be right there. So somebody tell me to the right, somebody tell me what the empirical rule says. If this is 50% and you're going to the right and this is less, and that's going to be around what? 0.49? Probably less than that. Probably 0.4995 or something like that. So we're going to go from 0.06 to infinity, or whatever it said, 0.06. So you just got to change one. So second, enter. And I'm going to change this to 0.06. .47608, 0.4761. Calculator says 0.4761. Yellow is negative 1.11. And of course, that's going to take up more than 50%. So that's going to be 50 plus 8, that's 84 right here. And 1.1, you're going to add 1.3. So I'm going to say 0.8500 for the empirical rule. So we're going from negative 1.11, second bars, normal CDF. Oh my gosh, we're over. What time's class over? 9:20? Oh yeah, so I had a brain bubble there. 9:25. Okay, sorry. Negative 1.11. Thought it was Wednesday. To 9999. Calculated, we said 8.5 and 0.8665. So yellow calculation is equal to 0.8665. And then the orange, .32. Well, 1.3, that'd be a third of 13. 3 will go into 13 4 times. So this would be 8. 8 and 2 is 10. So I'm going to say empirical rule for the orange is 0.22. 1050, somewhere around 10%. So we're going to go to 9999. So second answer. And I'm going to change this to 1.32. Delete 1.32. And enter 0.0934. And those are your answers. So let's type them in. So the first one is 0.2177. Try again. 0.73. I don't know what they want. Let me type in an 8. 0.2327. I must have typed something in wrong. Let's check that one. Second, bars, normal CDF, 0.73 to 9999. I don't know what I typed in wrong. 0.2327. I must have typed something in wrong. I might have typed in 0.78. I bet you that's what I did. Second entry, 0.78. Why did y'all let me? Y'all didn't say a word. Not say a word. Just let the teacher just go on through, not say a word. 0.06. Our future is doomed to hell. 0.4761. Next one. 0.8665. And the next one, 0.0934. Now, y'all feel a little bit better now?
Yes, sir.
It's amazing what that communication will do. These people sent those questions, and they feel better too. So the weaned on a pickle, tit on a bull, sitting in class, not asking questions, that doesn't get you very far. All right. Any questions? I don't know how many questions that is, but we went over quite a few. When's the test due?
Tonight.
I'm sorry, say again.
Tonight.
All right. Well, you should be able to finish it now that you got the questions filled. I mean, that was a good review. I mean, you should be able to knock the test out now. All right. I'm going to, let's see how many people we got in here. I'm just going to say everybody's here.
Are you going to post this tonight?
Post what?
Like the recording of this?
It should be on Teams, and then I'll post it on YouTube right after classes today. I usually post all my videos in the afternoon of classes. Does that answer your question?
Yeah, thank you.
Okay. All right. Let's go ahead and shut her down. Y'all have a good afternoon, and I'll see y'all Thursday, and we'll go into Chapter 8. See y'all.
Have a good day.
Bye-bye.